Hello and welcome to the Sigma-HSE ISO IEC 17025 accredited testing laboratory. Our laboratory measures flammable and explosible properties of your materials to aid in characterizing them with the goal of preventing and mitigating explosion and fire hazards. Our global laboratories test both explosible combustible dusts and explosive flammable vapors or gases to help you prevent an unwanted event. Our global laboratories will generate data on the explosibility and explosivity of your dusts, gases, vapors, and liquids. We undertake the following dust characterization testing for dusts and powders: dust explosibility screening, go no-go; dust combustibility screening; explosion severity test, P-max KSD; minimum ignition energy, MIE, with or without inductance; minimum ignition temperature cloud, MIT cloud; minimum ignition temperature layer, MIT layer; thermal decomposition for the safe drying of powder; limiting oxygen concentration, LOC; minimum explosible concentration, MEC. This combustible dust test is conducted to assess the behavior or severity of combustion propagation through a material deposit when ignited by an external ignition source. A small powder strip is formed onto a heat-resistant, non-porous plate, and ignition trials are performed using a hot 1000 degrees Celsius platinum wire. This test is used to determine if a powder is combustible in a layer form. Minimum ignition energy, MIE. The minimum ignition energy test is conducted to determine the lowest spark energy that can ignite a powder when dispersed in the air as a dust cloud. A purely capacitive generated spark is used to assess sensitivity to electrostatic discharges such as brush, spark, or transitional propagating brush discharges. An inductive spark is used to assess sensitivity to mechanical and electrical discharges. Minimum ignition temperature, MIT cloud. The minimum ignition temperature, MIT cloud, test is conducted to determine the lowest temperature at which a hot surface will ignite combustible dust or powders when dispersed in air. Minimum ignition temperature, MIT layer. The minimum ignition temperature layer test is conducted to determine the lowest temperature at which a hot surface will ignite combustible dust or powders when settled as a dust layer. Potentially combustible dust is placed onto an isothermally heated hot plate and formed into a 12 mm layer. Once an ignition temperature is observed, the hot plate temperature is reduced and tested. This is then repeated with fresh combustible dust until the lowest ignition temperature is established. We undertake the following flammability tests for gases and vapors. Flashpoint. Flammable limits, LEL and UEL. Auto ignition temperature, AIT. Flammable limits, LEL and UEL. This test is conducted to determine the lower and upper flammable concentration limits of chemicals that have sufficient vapor pressure to form flammable mixtures at atmospheric pressures at specific temperatures. Our global accredited laboratories provide a diverse range of tests, allowing you to define the basic material characteristics of your dusts, gases, and vapors, and further define their combustibility and flammability characteristics. These characteristics define the severity of ignition and sensitivity to ignition of your materials. This information will help you understand the hazards in your processes, add appropriate safeguards, and ultimately reduce the risk of your operations. Our laboratories provide consistent, accurate data that represents your real-world industrial challenges cost-effectively and with the shortest turnaround time in the business.